Hello everyone. Today we're going to discuss some of the properties of a triangle, and along with it we are going to discuss some of the examples where we can apply these properties. So let us begin. So first of all, let us discuss some of the properties of a triangle. So for the first property says angles opposite to equal sides of an isosceles triangle are equal. So we all know what is an isosceles triangle. Let me show you the figure. So say for example ABC is an isosceles triangle. Now in this isosceles triangle, as we know, two sides are equal. So which two sides are equal here? Yes, side AB and side AC are equal. So the statement also says that angles opposite to equal sides of an isosceles triangle are equal. So this is what we need to prove. The angles which are opposite to those equal sides are equal in an isosceles triangle. So let us prove it. So first of all, we'll write down what is given to us. We're given that ABC is an isosceles triangle in which AB is equal to AC. Then what we need to prove? We need to prove that the opposite sides, or you can say the sides which are opposite to the equal sides of an isosceles triangle. So as you can see, which angles are equal to these opposite sides, AB and AC? Yes, right. Angle B and angle C. So these two angles, we need to prove them equal. Clear? Now we have to do a little bit of construction here in this figure. So as you can see, we have drawn something called AD on PC. So what is that AD? That AD is nothing but it is the angle bisector of angle A. That means it has divided this angle A into two equal angles, or you can say it has made this angle half. It is divided into half. So we can conclude from here that angle BAC and angle CAD, these two angles are equal because this AD is the angle bisector. Clear? So in the proof part, first of all, we have to consider these two triangles, ABD and triangle ACD. These two triangles, we have to show them congruent. So let us show. First of all, we are given that AB is equal to AC. This is well known from the question itself, or from the figure itself, you can say. Next, angle BAD is equal to angle CAD. As I said a while ago, that these two angles are equal because it has been bisected by AD. So by construction, we can say that these two angles are equal. Next, AD equals to AD. Now in both these triangles, ABD and ACD, side AD is common. So AD will be equal to AD. So we can say that triangle ABD is congruent to triangle ACD by SAS, or side angle side congruence rule. Now what can we infer from here? We can infer that angle ABD and angle ACD, they are equal by CPCT because they are the corresponding parts of these congruent triangles. So we can say that both these angles, angle ABD and angle ACD, are equal. Now in short, we can also write that angle B is equal to angle C. So this proves our statement that angles which are opposite to the equal sides of an isosceles triangle are equal. So hence proved. Now let us move on to our next property. The next property says that the sides opposite to equal angles of a triangle are equal. Now this is just the converse of what we have done just now. So in the previous property, what we have done, this property is just the converse of that property. So let us see. So now we are given that the angles B and C are equal. Now we have to prove that the sides which are opposite to these angles are also equal. So first of all, let us write what is given to us. ABC is an isosceles triangle in which angle B is equal to angle C. Then what we need to prove? We need to prove the sides which are opposite to these angles are equal. So which sides are opposite to these angles? Side AB and side AC. They should also be equal. This is what is said in the statement. Now let us prove. But before that, again we have to draw the construction here. The construction is similar. AD, which is the angle bisector of angle A. So it has bisected the angle A into two equal angles, angle BAD and angle CAD, and both of them are equal. So let us prove. Considering again the two triangles ABD and triangle ACD, we have angle BAD is equal to angle CAD by construction. Then AD is equal to AD, which is a common side. And then angle ABC is equal to angle ACD. That is given to us. So we can say that both these triangles are congruent by ASA, or angle side angle congruence rule. So what can we infer from here? We can infer from this that AB will be equal to AC by CPCT. Clear? So this proves the statement that the sides which are opposite to the equal angles are also equal. Now let us see some of the examples where we can apply these properties. So the first example says, in triangle ABC, the bisector AD of angle A is perpendicular to side BC. Show that AB equals to AC and triangle ABC is an isosceles triangle. So let us see the figure and understand the question. As you can see here, AD you can see it is a perpendicular bisector. Why I said perpendicular bisector, although it is not written here? Because it has bisected this angle A, as well as it is perpendicular on the line segment BC. So it is a perpendicular bisector. Clear? So since it is a perpendicular bisector, as you can see here, the angle made on BC on both the side of this bisector is 90 degree each, as well as it has bisected angle A, so angle BAD will be equal to angle CAD. Clear? Now we need to prove that this side AB and side AC are equal, and if they are equal, then obviously this whole triangle ABC will be an isosceles triangle. So let us begin. First of all, with the given part, AD is the bisector of angle A and is perpendicular to side BC. Now what we need to prove? We need to prove that AB equals to AC and triangle ABC is an isosceles triangle. Now for that, we'll consider these two triangles, triangle ABD and triangle ACD. So what we have here? We have first of all angle BAD equals to angle CAD given to us. Now AD equals to AD, common side. And then angle ADB is equal to angle ADC. Each of them is 90 degree because it is perpendicular on BC. So each of them is 90 degree. So we can conclude that triangle ABD will be congruent to triangle ACD by angle side angle congruence rule, and from which we can infer that AB will be equal to AC by CPCT. Now since AB is equal to AC, so it clearly states that ABC is an isosceles triangle. So that is what we need to prove. Now let us move on to the next example. The next example says E and F are respectively the midpoints of equal sides AB and AC of triangle ABC. Now we have to show that BF is equal to CE. So let us see the figure first of all. As you can see in the figure, side AB and side AC are equal in this triangle ABC. Now we need to show that BF is also equal to BF is also equal to CE. This is what we need to prove. So let us prove it. First of all, let us write what is given to us. Triangle ABC is given to us where sides AB and AC are equal. Then we need to prove? We need to prove BF is equal to CE. So for this we have to consider two triangles, triangle ABF and triangle ACE. These two triangles we have to consider. And what are the things which are equal here? First of all, AB is equal to CE. This is given to us. Then angle A is equal to angle A. In both the triangles you can see angle A is common. Next, AF is equal to, if you see carefully, AF is equal to AE. Now how can we say both of them are equal? Because as you can see, AF lies on what? AF lies on AC and AE lies on AB. Now already we have seen that AB and AC are equal. So AE and AF, both are what? They are half of AB and AC, since they are the midpoints. So we can say that the half of equal sides are also equal. So we can easily say now that both this triangle ABF and ACE, they are congruent by side angle side congruence rule. And what can we infer from here? We can infer that BF will be equal to CE by CPCT. Clear? So this proves what is needed to be proved in this statement, or you can say in this question. So let us move on to the other example. In an isosceles triangle ABC with AB equals to AC, D and E are points on BC such that BE equals to CD. Show that AD equals to AE. Now let us see the figure. So here is the figure. As you can see, ABC is an isosceles triangle. So that means two sides will be equal. Which are the two sides equal? AB and AC. These are the equal sides. Now D and E are points on BC. Now they are not midpoints. They are just points on BC such that BE is equal to CD. This is given to us. Now we need to prove that AD equals to AE. So let us begin. First of all, what is given to us? ABC is an isosceles triangle in which AB equals to AC and D and E are points on BC such that BE equals to CD. So we have written what is just given in the question. Now what we need to prove? We need to prove AD equals to AE. So which two triangles we'll consider? We'll consider triangle ABD and triangle ACE. These two triangles we'll consider. Now in these two triangles, what are equal? First of all, AB equals to AC. This is given to us. We'll mark it as equation 1. Then angle B is equal to angle C, because these are the angles which are opposite to the equal sides. So as you know that angles which are opposite to the equal sides are equal. So angle B will be equal to angle C. That will be equation 2. Next, BE will be equal to CD. Now it is given to us BE is equal to CD. But do you think that BE and CD lies in those triangles ABD and ACE? No. In the triangles, if you see carefully in the figure, in the triangle ABD and ACE, only the side BD and CE is there, not this BE and CD. So we need to subtract this part DE. This is the unnecessary part in both these triangles. So this thing is not required. So we need to subtract it. Then only we will get BD and CE. So if we subtract DE from BE and CD, then what do we get? We get BC equals to CE. So that will be equation 3. So in this way we can show that BD will be equal to CE because we have subtracted equal quantity from both the sides. So from equation 1, 2 and 3, now it is easily understood that this triangle ABD and triangle ACE are congruent by side angle side congruence rule. And from here we can infer AD will be equal to AE by CPCT. So I hope you all have understood the properties of the triangles as well as the examples, and this brings us to the end of today's video. So that's it then. Thank you and have a nice day.